Okay, so good day, everyone, and welcome to the Women in Data Science Trinidad and Tobago. These are our February Datathon workshop sessions. I am Dr. Addison, and my team and I today will have a nice interactive hands-on session with some of our feature speakers based on data science methods at a glance. Today we'll be featuring Mrs. Alleanna Lawrence and also Miss Fazeeia Mindy. Just to get a sound check, are you all hearing me clearly? Is everyone hearing me clearly before we go forward? You can let me know in the chat before I proceed.
Yeah.
Yes? Okay, excellent. Right, so just to remind persons about our challenge and the climate challenge, that really was the beginning of where we started in terms of how we proceeded to create workshops surrounding a Datathon challenge from the WiDS global movement. This is our 2023 challenge hosted on Kaggle. So even if you aren't involved in the challenge, that's fine. I know a lot of you are participating. I would like to have some insights to help you along. So these are the sessions that would really help you to hone in on those skills. And of course, it was really crucial for us to really mention that climate change in itself is a large problem that we have globally. So we are really happy to have persons interested in using data science techniques to be able to tackle this problem. I would just like to make a little bit of a segue into wishing everybody a happy International Day of Women and Girls in Science. Today, the UN recognizes all of the achievements of women and girls in science and really the role of women and girls as it relates to the Sustainable Development Goals. So the theme this year is really innovate, demonstrate, elevate, advance, and sustain to bring everyone forward for sustainable and equitable development. And I would just like to show you all a quick video. I will stop sharing quickly just to give you a video, just to kind of give you some context on how this looks for our theme based on climate change. It's really nice that they actually gave us a little bit of a, let's see, you let me know if you're hearing this as well. I'm going to play a video for you all now.
The science can get complex, but the basics of it are really actually simple. We understand greenhouse gases in our atmosphere. We understand that we're putting more of them in. We can measure that. And we know that's changing things. So when you understand that, what we're learning is how it's changing and how to make those connections.
If you think about a complex problem like climate change, you need everybody coming to the table with innovative solutions. And that means people from all walks of life. You need to have women's perspectives.
So that was really just a little bit of a segue into how really, women and girls could have, some of these really amazing achievements and help the world in terms of these social impact problems, right? Just to make sure everyone is still seeing my screen, right? If you could let me know in the chat. Yes? Okay, great. So as we move forward, I just want to remind you all that we are hosting a number of events. So in addition to the workshop that we have today, we also have one next week, which is a really great follow-on workshop with another feature speaker to kind of give you a context of how to use these machine learning models after we finish training them. So you could actually visit our website to get more information on these events. And also we have some March events coming up as well with some technical talks and also a fireside chat with some amazing women in the field. So I don't think you'll want to miss any of these events that we are hosting. So Just a reminder, if you want to participate in the Datathon challenge, this is all the information here, and it's also available on our website. So you can always feel free if you need to reach out to us to find out any more information on it, let us know, and you can also contact us via email or on social media. So before we get into our session today, I just want to bring to your attention, for those of you all who were able to fill out our little icebreaker, I'm going to bring up some of the results of that. So let's see if we can present it. I know a few times I'll keep asking you all if you could see my screen, but just making sure again, can you all see my screen? These are some of the words. Well, actually, it's a bit of an open-ended question. So I see some person said they want to be introduced to other people and techniques that they can use in data science. Some person said machine learning techniques they would like to learn today. Someone else said they are novice, so they would like to learn more about the subject. So we're really happy to have you on board. Another person said they would like to determine if it's a career path they would like to take. Someone else said they know very little about data science, so they hope to get an understanding and to contribute. I'm liking that. Oh, since I'm weakest, no, well, no one is weak. We will always help. We have a lot of great mentors to help you all along, right? Ways to improve any competition, prediction methods. Someone said they hope to explore data, pandas, machine learning, and to get insight into model prediction metrics. So I'm really happy to have you all participate and to let us know what you are looking for and from this session. So thank you very much for that. So moving along. Right, so this is what we came here for. This is our workshop session on the data science methods at a glance. And today I am very, very happy, honored, and excited to have these two amazing women who are going to give us a rundown of these methods in a very nice, hands-on, interactive, collaboratory notebook. So we will have Mrs. Alleanna Lawrence. She is a data science at Musora Media Incorporated in the United States. And we also have Ms. Fazeeia Mindy, also known as Mindy. She is a data analyst at Digicel in Trinidad and Tobago, our home country. So we like to have these two speakers come and give you a little bit of a context in some of the background. So Alleanna, would you like to give our audience some of the background as to your field, how you got into it, and anything else you'd like to add to that? You could start, and Mindy, you can follow.
Sure. Thank you for the introduction. I'm Alleanna. It's nice to be here with all of you. So I started in university, actually getting into data in general. I was more on like a public health research area of study, but then a lot of data was involved in that, and I really enjoyed the problem solving and learning how to code. The first time I had coded was in university, so I was just kind of getting my bearings and learning from my peers around me. And then by the end of my university time, I was involved a lot in the data science education program and really bringing data science concepts to like not traditional data science classes. So I love this Datathon in particular because it really brings in climate and social justice and all of these other avenues that really need context. So we can do all of this like data analysis, and we'll be going through that today, but ultimately it's the people behind it who really bring forward unique insights. And so that's what is going to bring the best models and bring the best data analysis. So now after university, I worked a couple different positions, and now I just started as a data analyst or data scientist at Musora Media Incorporated. And so it is a music education company. So really data science can be applied anywhere. I get to kind of work with the different instruments people are learning, looking at user behavior and being able to inform business decisions. So it's a lot more like business central than before. But yeah, I'm excited to talk to you all today, and who knows, maybe next I'll be working for a different organization doing climate or doing public health or doing something else. So there's really a lot of possibilities, and that's what I like the most about it.
Yes,
Thank you.
that's so great. Thanks so much, Alleanna, for that. And we're really, really happy to have you on board to share your expertise about some of the methods. I know it'll involve some feature engineering, model testing, training, validation, those types of things. And also your co-presenter is Fazeeia. So Fazeeia, would you like to give our audience a little bit of your background and how you got into it and what are you working on at this point in time?
Yeah, sure. So, like she said earlier, you could call me Mindy. I'm a data analyst at Digicel. I graduated about, I think, 2 years ago. And I got into data science through TT Labs, which is a local research lab, where I led the National Geographic Proper Foundation TT Labs research project into applying machine learning to computer vision data. And it was on, I guess, water stress in plants. I've come a long way since then. So now at my current job, which is vastly different from a research position, I spend my time building models and trying to integrate legacy systems with newer technologies to do things like financial forecasting and change predictions from a corporate point of view. And overall, I remember one of the questions being, would it be something that you should look at as a career? Definitely, because everywhere needs to have some kind of analysis being done on their data. So it makes sense as a future prospect. I did my first degree in environmental and natural resource management and biology. And then I went back and I did computer science, and now I'm just developing a career in data science. And I can see how I can apply it to everything that I've learned in biology and environmental. And most of the projects that I pick up usually are in that area. So yeah, that is a bit about me.
Very nice, very nice. So we're really, really happy to have you both here to share your expertise. Just to let you all know, I know in terms of the interactive components, we will be also sharing some extra resources for some of you who are more beginner level. And we also have on our YouTube page some of our initial tutorials as well. Mindy would have been a part of those to kind of give you a context on the use of Python and all these different types of things to help you along the journey of understanding what sort of software you can use to help you with data science and machine learning methods. So that's also available. And I also like to let you know that she will be doing a technical talk on AI in agriculture in March, on March the 4th. So if you want to get some context of some of the projects she spoke about, you could feel free to also sign up for that on our website. So let us not waste any time at this point in time. So I'm going to invite our two speakers now to, let me stop sharing my screen, and they can proceed with the presentation. Anything that they use within the presentation, they will send to you in the chat. So, so you all could take it away. The floor is yours.
All right. I'm wondering, I think I will start with sharing my screen, and then when we switch, then we can switch screen sharing as well. So bear with us. I think either everybody has, okay, I will also send the link so you guys can look at it and follow along to this notebook as well. Okay, perfect. Rihanna sent it already. Thank you. Yeah. So I will share right now. On the left, there's a little like kind of brief outline, but we'll go through just like the start. So if you haven't worked in a data science notebook before, this is Google's data science notebook. Kaggle also has some too. I don't know. I think I have some on this tab you can see. So this is a similar notebook. Mine is in dark mode. Sorry about that, but this is these are different cells that you would be able to write code in and run. And then you can also add text kind of explaining what you're doing. So this was the workshop from last week. So we were able to have like all of the code here for us. And you can copy it and edit it yourself later. This is where we will be doing our entire presentation. So some of our information is in here, but also all of the code will be available to you. So you'll be able to, you can comment on it, or if you come over here to the right side, you should be able to, for you at least, or I have edit access, but for people who have comment access, you'd be able to comment, and then you'd also be able to make a copy in your own, like save a copy in Drive. So you'd be able to save it in your own Google Drive, just as a background. Also, throughout this entire thing, if anyone has any questions, we have plenty of time. So you can add the questions in the chat. You can raise your hand and I can pause. This is going to be an interactive style. So let's get started. We are going to be going over data science methods at a glance. We're going to start with importing kind of the necessary Python libraries, loading the data, and reading it in a training set and a test set. I'll explain why we do that and what that's for. And then we're going to go into data cleaning and kind of the implications behind that. The main part is going to be like feature selection and training this model, and that will be when Mindy takes over. And then finally, we'll go over the predictions and how to evaluate a model and understand if it's doing well and kind of some of the nuances that come with that. Finally, we will go over some code in order to submit for Kaggle. So this is one of the things that they give you a submission example. And so we'll go through one way of how to make that submission example happen. All right, let's get started. So can everyone see my screen? I've never checked. Everyone can, right? Okay, cool. I'm assuming that everyone can. Here we are going to start by importing the necessary Python libraries. So each of these libraries has kind of a different use. We may not use all of them. Sometimes you can import libraries that you don't use, but a lot of them we will later on. And once you import it, you have it for later. And Google Colab has a lot of these already installed, but you can see that these dependencies are really important. And a good part about using a cloud notebook, so like a notebook that's run on the internet instead of on your local machine, is you kind of have less issues with importing libraries, which can be pretty hectic in Python sometimes. And then specific to Google Colab, you can mount this to your drive. So this is the code to mount it to your own drive. So if you download the training data and the test data from the Kaggle website and you put it into a drive, then in your own Google Drive, this Colab notebook would also be in your drive. So for example, you can see my drive here, and I have like a WiDS Datathon 2023 folder in my drive. But then I also have these Colab notebooks. So once you start Colab notebooks, you can open it up. And this is where I have a lab from university, and I have this data science methods notebook that I was working in. Any questions so far on Google Colab and how it works? Cool. So we are going to continue with reading in the data from Kaggle. This is sklearn. It's a popular library for machine learning, and a lot of what you need to do, a lot of the math of what you need to do, you can use the different sklearn sub libraries and packages. They have a lot of explanations and examples on their documentation as well. It's also called scikit-learn, but when you type it out, it's usually sklearn. And they have a method called train test split. So that's what I'll go into a little bit deeper later. Also, some cloud notebooks have these methods available for you, so they pull in the documentation. So I kind of highlighted this train test split, and I was able to look at the function itself that does what we want, and then you can even open it in this tab and get more information. So it's really helpful for learning, understanding how each of these methods work and how you can use it for your own specific example. Oh, they even have examples. I didn't even know this. So as you're coding, as you're getting into it, really try to utilize the resources on the documentation and reading this kind of stuff. I mean, I still do this every single day. There's always going to be new libraries coming out, and there's always going to be things to learn, and kind of understanding where to look for that is definitely more helpful than knowing all the math behind it, or having a ton of coding experience. So anybody can start and learn how to do it. All right, so here is my path. This path goes directly, this is like the folder path of where my drive is. Another way to do this is coming in here to drive. So it'll have your drive in here. And then a lot of things will come out, but like if I go into my WiDS Datathon 2023 and I click on these 3 dots, I can copy path. So that's what I did, honestly, and I put it right into here. So the reason I'm going over this is just because everyone is different. Every cloud notebook is different, and some of them have little nuances like this. And I just want to make sure everybody has an understanding of this part. So after we go through the training set and the test set, which are both given by Kaggle, we are going to kind of start exploring. So exploratory data analysis is its own subject, but it's a really important part of our whole data science lifecycle. So we want to clean our data, understand it, explore what the different columns are. That's the part of the understanding the context that's really important. So anybody that has a background in the domain that the data is part of, like if you're looking at financial data and you have a knowledge of the markets, for example, that's going to help you in this part of understanding which columns to clean, and you'll see as we get into the code a little bit more. So first step is, I'm going to fix this typo. First step is going to be dropping the missing values. So a lot of data is not clean when you get it. People input data differently. There's mistakes. Just anybody who works with data in the real world knows it is a huge part of the job is cleaning the data. And that's another huge part that we want to be mindful of when we're making the decisions of which columns to drop or what to fill in the missing values with. All of these decisions are what can skew data to be a certain way. If we need to question kind of why we do this and understand some of the implications. For example, if I have a region of the US for this weather data, and the data isn't completely clean, or it's not working well, and I decide to discount it, I still need to think about like, who is that affecting? What decisions is this data going to be influencing? And I think next week the workshop will go into more about the implications kind of behind a lot of when you're making models and what they're going to do after you train them and test them and things like that. So we are going to get into kind of the training part. So in train, we're assigning it to drop null values. And then we're also going to fill in these missing columns and check to make sure that there are no null values, which there isn't. And then another common thing that people do is do a dot describe. So this gives us a brief overview. We get the mean, standard deviation, and the quartiles of different columns. So it doesn't really apply to latitude and longitude, right? Because those aren't really things that we're checking. That's just a location. But a lot of these other columns, we can kind of see where the data lands, what the distribution is, maybe if there's any outliers or things like that. That doesn't really apply here, but in data, a lot of times we have to keep in mind what the outliers are and whether or not to include them. That's one of those important data cleaning decisions that has real world implications as well. Okay, so I'm going to pause here. If there's any questions, I'm going to keep pausing, even if there's no questions, just in case. And then also you can save them for the end, whichever works, but we'll continue. Another way that we will be able to understand our data before we get into the feature selection and model training is with visualizations. So Mindy did a lot of this code, and she was able to, this is a couple lines, and it's matplotlib, which has a couple different KDE plots and subplots. And these give us an idea of where the values are in these different columns. So it looks like we were able to see kind of the averages where these outliers are, and it gives us a general overview. Okay, I see something in the chat. How do we know if to drop the null values or to impute the null values? This is a really good question. And it's frustrating because we don't know, it's not a rule each time. If you can drop the null values, you have to check to make sure, like a lot of times if you drop one value in a column, you'd have to drop that entire row. And if you drop that row, it's important to consider whether those rows are going to be important in other places. So if you also want to impute the null values, that is when you add something into them. A lot of times people will put 0 in, for example, but that's in the context of the column. So if I have like a gender column and some of them are blank, if I just put 0, it doesn't really match, right? So that's why getting to know your data is really important, and understanding that. So why is there no validation data set? This is a good question. Right now, we're just doing training and test. That's what the Datathon gives us. We're just doing train, test, split, and doing those two. But cross-validation is another technique, probably for like a different workshop, that is really helpful in making your model be the best it can be. And then, thank you, Nicholas. Yes, so after dropping or imputing, it's also best to visualize the data, do a check, maybe see how much it changes, and think about, like, I sometimes do a count of the rows to make sure that too many of the rows aren't gone. So that's why the best thing at the beginning is to look at how many null values you have, and then you can decide what to do with them after. These are really good questions. Thank you. So next we will continue. This is also a probability plot. A lot of these are just examples of different visualizations that you can make. These are the functions that made it possible to make those and make them look pretty like they did. The next thing we're going to kind of get into is, this is like model selection. This is more of the code that Mindy will go over, but a lot of what we do is dropping the irrelevant columns. If you train your data with irrelevant columns, it'll still go into that training of the model. So you want to make sure that you're cognizant of that. And then this is also some more cleaning. We want to get it into the right format. So at first it said start date and it was in one format, but it was easier for our purposes to look at the year, month, and day separately. And one thing I want to point out is whatever you do to your training set, you also want to do to your test set. Every single thing, they should be the same. And I'm going to get into that next. So one of the functions that scikit-learn has is train, test, split. We looked at it up at the top before. And you input your data, you input your Y value. Your Y value is the column that you are going to be predicting for. So your training set will have your Y column as well. And the reason that we split it, we have one that's a training, and that is to train our model, and it has more data. And then what the split does is it gives us a test size. So it takes away the testing, and it has like a smaller set. And you can see here that there's like splitting of different training and different tests, and this is all for some of that validation in order to test different data. So every time that you input data into a model, it's not going to always behave the same way. Like think about if you have like a line chart and you have different data points. Like if you put a different set of data points, even if it's from the same table, but like a different subset or sample size, that line is not always going to be the same. So that's why it's important to have a large amount of data too. And that will affect it in different ways. And sometimes, there is such thing as too much, especially for memory and speed and things like that. But overall, if we're making decisions based on a small subset of data, a lot of times it's not going to give us a precise answer as well. So like there could be this trend, but if we don't have enough data points to show this trend or to make this prediction, then it really isn't that valuable, right? Because you're not training it on enough information. We're only as good as the information that we have. And so a lot of times there's different standards for test size. This test size is going to be 1/3 of the overall data. And we can see kind of the different set of rows. one of them has all of the features, so that's 246, I believe. With this is the one, so these are the Y. This is the Y is like the value that you want to predict. So that's what we'll get to. All of these have different like weather features and patterns. Mindy will get into more of that. And then the test, like depending on how many features we do. So the training, we're doing like 3 features, like we're just picking 3 of those in order to predict our test predictions. And then this one is 5. So each of these will behave different ways, and she'll go into this more too. But the reason we want to split is because if we train on a data set and then we don't test it on other data, then that model will just be for that one. We'll only know its performance for that one group of data. And we want our model to be able to perform well on data it hasn't seen before. So that's what the test data kind of acts as. That's kind of the best way that I know how to verbalize it. But it took me a while to understand what that was too. But now we got it. So after that, oh yeah, I have a note here. Whatever you do to your training data, you must do to your test data. So just think of them as 2 data sets that should be the same. One is a subset of the other, and the test data is just like check. And then to avoid something called overfitting, which we'll get into. Okay, so I think we're now at the point of talking about feature selection and the XGBoost for climate data. So I will pass it to Mindy, and I'll stop sharing my screen. So Mindy, if you want to share yours. And then I'll come back in like quickly at the end to talk a little bit about the submission. And any last questions, you can ask questions in the chat and I'll answer them in the chat as well. All right, thank you.
I think we have a question from Guy.
Oh, yes, I see.
Yes.
Yes, so I can answer that before Mindy starts. So if it's on data that has never been seen before, how do we know what to clean? That's a good question. So imagine like you have your training data and you cleaned all this stuff on your training data, and you like the model is training like when you fit it. So like, for example, without going into too much of the math or the visual, all this data gets fit to a model. That model now knows what was in that data, but the format has to be the same as what it gets in like the data it's never seen before. So that's why we want to clean it in the data format is the same. So the cleaning is going to be the same, but the actual values are the things that it hasn't seen before. So for example, if a column is has a certain set of numbers, okay, you know it's clean, you know that there's no missing values, but the test data is like just a different set of numbers, and you want to still be able to predict based on that. So that's all. Thank you.
Hi, so my name is Mindy, like I said before, and I'll be touching a little bit on feature selection. So a lot of this here was generated by Shannon Ray. She created these plots. These are plots based on the more numeric features of the data set that we have, right? So just keep that little thing in mind as I go along, because I actually use that a little later down, right? So feature selection is the process of, is the process of feature engineering or pulling out certain features that would help create a predictive model that is fairly accurate. And you want to do that by sort of reducing the input of variables. And feature selection techniques are employed to reduce the input of variables by using things like eliminating redundant or irrelevant features. So you would find that not all your features will increase your performance on your model. And when you narrow down the features to the more relevant features, you tend to have a faster functioning model, which is always really good. I think we have over 200 features right now in this current model. And some of that is noise. So it is really a really important task to do, and you have to do it very carefully, and you might find it is a little repetitive in some cases. And it is important because you want to decrease overfitting, improve your accuracy, and reduce training times. So you want to make your algorithms, perform better, faster, and not be overfitted or underfitted also. So I kept a lot of the hyperparameters in the models that I created the same. However, that is something that you can play with and change up, and it would change the way your model behaves. It can increase or decrease accuracy. It can increase or decrease overfitting and underfitting also. So there are some methods for feature selection. We'll talk about the wrapper method. We'll also talk about the filter methods and the embedded methods. So you're looking at a certain set of metrics for your wrapper methods. And you would do things like forward selection or backward elimination and recursive feature elimination. So forward selection is simply just starting with like one feature, maybe two features, and then subsequently adding on features and rerunning the model to see improvements in the model performance. And if adding a new variable doesn't improve its performance, then you interrogate it a little bit more to determine whether or not it is necessary for your model, and if it should be even included. Backward elimination, as it suggests, is simply just taking all the metrics and then pulling out one by one and seeing if the performance metrics that you took out changes as you remove or drop features. And then you have a recursive feature elimination, which really is an algorithm built to find the best performing subset of features using greedy optimization, which iterates through creating models and determining what are the best and worst performing features. There are packages that utilizes these things, but I think I showed it in a pretty manual way in this notebook. Then you have things like the filter method. So I think last week they would have spoken to you about Pearson's correlation, which is this year, but well, Colab doesn't load it too well, but I know Shannon Ray generated a really big, nice one of this. I was looking it over in the notebook. And it's used to quantify the dependence between two variables, especially continuous variables, which is what you're dealing with here. There's also things like LDA, linear discriminant analysis, ANOVA, which stands for analysis of variance, and chi-square test, which all can be implemented to really see the relationship between the features that you are examining. You don't want things that are too closely related, but you also similarly don't want things that add unnecessary, I guess, noise, space, takes up space and doesn't really add to the performance of your model. So that is a major factor in that. And then you have embedded methods like ridge and lasso regression, which have built-in penalization functions, which can reduce things like overfitting. So there are two things that I want you all to understand with feature selection. There is feature selection and then there's extraction. The key difference between feature selection and extraction is that feature selection keeps a subset of the original features, whereas extraction tries to pull out or get new useful features from the existing data. And then there's also feature selection versus dimensional reduction. And this is where you reduce the amount of dimensions of features, which is in contrast to feature selection, where the features selected are always a subset of the original features, right? So a lot of the models that I built, well, all the models that I built today are XGBoost models. It is one of the more helpful ones. So where I work, one of the most important things is to derive some kind of insight from what it is you're doing. And trying to find insight into the performance of your model is really hinges on the features that you use and being able to optimize the parameters of your model in the first place. XGBoost is an extreme gradient boosted decision tree. I find from my personal experience with it, it really does lend a lot of insight into what things influence other things, right? And if you think about climates, on a large scale, having high humidity in one area does eventually impact having rainfall in another area a couple of days later. So you see that relationship happening a lot, even if you look at purchasing behavior with people, rainfall, something like rainfall could increase credit card payments or credit card activity. So there are lots of relationships that happen. People are basically data points, and these data points can be quantified, and being able to map the relationship between those data points, I think personally, is really well described when it comes to decision trees. So I spend a lot of time building them. So in this particular example, I did build a lot of decision trees. So I think if you, right. So these are the, this is the training set, right? This is the original one that it came with, which is all the features. Remember, we talked about elimination. So if you do an elimination, you would start with probably this and then continuously drop one column, and see how it affects your performance, model performance, right? In this one, what I did was I pulled out 3 features at random, and I built a model using those 3 features. I dropped this feature from the data frame, and I built a model like using that and that alone. And then in this one, I pulled out all the mathematical features, continuous data features that Shannon previously illustrated. I think it was higher up. Hold on. Here, right? I pulled out these specific ones and decided to build a model just using these, because you can see, you know, the relationship between the distribution of data points there, which is kind of interesting. And what I did afterwards was I built the models, I trained them, and then I looked at feature correlation between you know, the model and the output. So if you go down here, I touched a little bit on, give me a second. Yeah, I touched a little bit on some metrics to determine. So I picked a metric, which was R squared, and I trained these 3 models. As we can see up here, if you want to actually see the model train, you can just change, you know, your verbose to true. But I had it false for these, so it doesn't take up too much space. So yeah, you use the import for the XGBoost, and then you fit your models. This is the first one, which is all the features. This is the second one, which is just 3 features, and the third one is the 5 features. And as you can see, we got different scores for each one. Now, for the first one, it obviously has all of them. So you can see that it has a high accuracy, R² value, as whereas these underneath here don't. You could see the one that had 3 features have a R² between, this is expected, of course, between reg 1 and, well, reg 0. Sorry, reg 0 and reg 2. I name my models reg. It's just a quirk at this point. And this is a script that I kind of modified from work. So yeah, that's just the name of my models. You don't need to worry about it being something different. And here, we did some imports for, I use sklearn to do these particular mean squared errors and R2 score. Alleanna will come in and she'll speak to you all about these particular scores of evaluation. But the takeaway is that lower down, you will see that there are 3 different libraries that you can use to get these particular scores. However, what I would suggest is that since you're new to it, you simply use one library and you pull out the metric that you want to use for elimination or elimination or forward selection or backwards elimination. So you choose one of them and you compare one of them and you make sure that it is within the same library that you're using. If you I know a lot of you are relatively new to it, so I would suggest that you probably do a little Googling. I have a little YouTube channel. This is not mine, this is StatQuest. I find StatQuest always sort of take you through how XGBoost is built and made, and if you are a beginner, it is a really good place to start off and go. So yeah, these are the feature importance based on the 3 different models created. So we see all the features here, 3 features here, and the 5 features here. And as we can see, feature 2 has a really high importance overall in the model. And this was something I did out of my own curiosity. I went to, I'm sure you all know ChatGPT, and I put in all the features into it, and I asked it the question basically, which features are of more importance than others. This is not, you should never just accept this. This is something you can go out and test now, and either prove it right or prove it wrong, because that is the scientific method, testing your experiment, and this is basically experimentation at this point.
Gayatri wants to know if you started practicing for fun.
So I did computer science, this special at UE, and I did all the math courses, and I did, well, in computer science in the CIT, and I did because it was easier, because it required less interpretation and more fact. And after that, I found Professor Hussein, and he was doing really interesting stuff with the climates and the environments. And because I had a background in it, I was just like, could I help you? And he was like, yeah, you can help. And I just started helping, and I went down a little rabbit hole. You all know how it is. You start researching one thing, and then it's like 3 o'clock in the morning, and you're on a random page, and you're wondering how you got there. It happens a lot. And it's a really easy thing to fall in love with. So yeah. So yeah, I'll pass you back over to. Oh, do you all have any questions? No questions?
No burning questions for Mindy?
Feel
Okay,
free if you all want to ask. I'll answer anything. It doesn't have to be about the model or feature selection. It is its own topic in computer science. Like you can go and do a whole thesis on just how to do that. All right.
Steven says just now he'll have many questions, so I guess you all could proceed.
All right. Yeah. So I'll let Alleanna take over from here. Yeah.
Okay, great. Thank you. So I will share my screen one more time. Here we go. And we'll kind of go to the last couple code blocks. I will preface, it was working for me a little bit ago, but now it's not. But I'm going to just explain the concept behind it, and then I'll make sure to fix the code for like when the next time you guys like click the link, it should fix it. But essentially what this is a function called Kaggle, and this is bringing in the like, I'll show you. Let me get rid of this cell actually. So the Kaggle competition will have a sample underscore solution.csv, and that is what your like quote unquote solution will be. And it's going to be a list of predictions. So you saw Mindy go through her different lists of models and how she was doing that. And then you can decide which one of those models that you fit to a certain prediction. And once you have like done like .predict, basically, you'll have your list of numbers, and that's what you are submitting to Kaggle. It can be kind of confusing and stuff too, but I'll also show you the list of or the sample solution and what it looks like. So if you're in the WiDS Datathon Kaggle and you go over here to submit predictions, you'd like drop a file. So you drop a CSV or a zip or whatever, which way you want. I usually do a CSV. And in the data, it has, along with the train and the test data.csv, it'll also have a sample solution. So you'll see it has one column that has this name. And so that's the column name of the Y that you're predicting. And then it'll have just an index. And the way that I understand it, I'm not currently on a team, but the way that I understand it, usually this is just some like ID if you're predicting something. So I think it's just an index. That's the way that I used it, but correct me if I'm wrong. And then how we make our data look like that is, where is my Google Lab? Right here. So what this function will do is you'll make a data frame essentially with a column, and then it'll have an index, and then I was making the index like its own column. So you'll have one column with the index and one column with your predictions. So that is coming from WiDS. And WiDS is, I chose Pred1, which came from Reg1, which was one of the models that Mindy had used to make her predictions. And then Pandas has a 2 CSV, and this will put it into a like submission.csv. And then once you run the Kaggle, it should show up in your file. And yeah, like I said, I'll correct this code, but essentially this is what you want to get to. Another way to do it too is like if you have the output, like you put it into a spreadsheet, like you just have to get that list of numbers and submit that. So that is just the last possible part, a little like kind of tutorial. And if there's any questions on that, you can let me know as well. But that is what we've prepared. So we still have time if anybody wants to go over anything else from what we presented today. Next week is also another workshop that I'm really excited about, talking about how your model performance over time, especially with weather data and some of the implications that come with that, like what you do after you train your model. So thank you for being such a great audience. I had a great time and really happy to be here.
Thank you so much to two of our speakers. And we know that you all will have to have time to run the code and all these things as well. So feel free to reach out to us I think there's a question in the chat. Can you suggest any peer-reviewed research journals on machine learning? I see Mindy also dropped one. Anything on your end, Alleanna? Any resources that you think would be useful for them to use?
Yes, I have a couple different papers, especially on like climate. I think I will find it right now.
Yes, sure.
And I'll drop a link. There's the Berkeley AI Research Climate Initiative. And so this team will have some papers, but also just there's like a website. So you're able to kind of look and see the different projects that they work on and how it applies to it. But also in general, I think Google Scholar has a lot of universities, but I would recommend looking at different universities that you're interested in the research of. And like I went to UC Berkeley, but also, you know, Boston University, MIT, different like universities that you can think of all have different research going on there. And a lot of them apply to different fields, which is really exciting. Personally, I'm really interested in education, you know, predicting class schedules and things like that, understanding students and like using machine learning. There's a lot of research on that as well, which is
that excites me, Alleanna. I actually did not know that because in fact, you know, what I do in terms of student retention, I'm glad that you talked about schedules because I like the aspect of using machine learning and data science to learn the behaviors in terms of students, in terms of education and big data in education. So that's really, really great to hear. So I'll probably be asking you some questions on that when I get a chance as well.
Okay, yeah, I will put Zachary Pardos is a professor that I know that that's who I thought of when I was thinking that. So I put his name in the chat. If you look him up at UC Berkeley, that was what kind of also got me into it. So anyone else?
Oh, excellent, great. You see, we all learning something new today. So anybody else has any questions for our speakers? Anything at all? I mean, it's now an open space, so you all could feel free to ask any questions aside from the talk. Anything else that y'all would like to find out? I would also post, I'm just putting the website in the chat if y'all want to see their LinkedIn profiles, y'all can do so. Y'all could go and check out both of their LinkedIn profiles and contact them as well. Anybody else has any questions? So Alleanna and Mindy? I think I'm hearing so if I'm please forgive me if I'm pronouncing it wrong. You have a question?
I think their mic just may be on, but there's a question about the YouTube channel for beginners.
That's which is it from you, Alleanna, or is it from our side? Precious, which
that was I was talking about
from Mindy.
Yes, earlier. So like they have let me try, I think I opened it earlier. So they have like, well, you know, most machine learning models have its roots in statistics and, you know, they explain most of it in a really nice, friendly way.
Great. So she'll drop that in the chat. And just to let you all know, we'll also email all of you with the recording as well as the some of the links that our speakers dropped today. And you'll be able to have access. I think Aidan is also asking, do you have recommendations? Yes.
I can answer.
Yes, go ahead.
There's a Towards Data Science article that I have looked at, and it's actually called Pandas Tricks for Imputing Missing Data, that has more of like a direct understanding or like documentation. So it's easier than what I can probably just say, but essentially I kind of break it up into a couple different options. Either removing that row, which has its own implications, inputting a mean. So like if you get the value of a numerical row or a numerical column, you can input the average of that column. And so it doesn't skew the data that much and you get to keep the row. And then another option is to put a 0, especially if it's binary, or do like half 0, half 1 if it's like zeros and ones, or just make it 0 if it's something that you can't put like a mean or a 0 and 1 for. The article has some like code that you can use to do that. I think there's like different like it's like .fill NA. So that would be the main like function in pandas that I would use. and you would do like your data frame or your column of your data frame, and then you would put fill NA, and then you can make it either the mean, you can make it 0, and then you can decide whether to edit that instance or to like kind of make a copy of that instance if you want to keep your previous one. Thank you for the question.
That's great. Anybody else? I'm just checking the chat. Anybody else want to turn on their mic and ask a question? I think someone, I'm hearing
Can I
someone
ask a question?
Yes.
How much of the audience like deeply considering data science or machine learning and in school right now, like whether it be SPCS or UE or anything like that?
I think some of our audience is actually international as well. So based
Oh,
on Mindy's question,
university in general.
yes. So anybody wants to answer Mindy in the chat about if you are considering data science, if you are currently at a university and you want to consider data science, or you're currently in a data science program? Stephen, you are in, what's your background again? Oh, I see Gayatri is saying that she's currently pursuing AI for her PhD dissertation in aviation. Wow, that is a really nice, I like to hear these innovative fields. Deandra is saying a little bit. Who else? Considering it and at a university, Nicholas, electrical and computer, right? Great. Mindy, any thoughts you wanted to share with them? Any insights, any advice? Mary said she's considering studying data science. Liana said she's starting a data science bootcamp in March. Oh, that's great. Adobe's Digital Academy. Okay, that's something new to me. I've never heard of that one. So that's to mention. And feel free all to share resources with each other. In this community, we like to share with each other. And I'm really happy to hear that you all are doing these things. Precious said she's currently at UE doing a minor in management information systems. So I love to hear all these hybrid fields. Nicholas said, what is the best to start with, data science or machine learning? Who wants to take that question? Alleanna or Mindy? Or both of you?
So I jumped in the deep end of it. So I learned the machine learning and the computer science techniques, and then I started learning the data science background. But yes, the Datathon is one of the best ways to start. Because when you see something and you produce a model, it feels really good. Alleanna, what's your take on it?
Yeah, I think one thing that I also always recommend, I really like working with other people, which is why I said the Datathon, kind of joking, but also kind of true. I really like being able to talk through situations and ask questions in real time, and figure out things like together with others. But I think another great way is there's a lot of resources on YouTube. If you learn with videos, I think finding the way that makes it exciting for you. And the way that it was exciting for me was being able to work with the kind of data that I thought was cool. So like I started with different like public health problems when I was studying that. And then when I moved to education, it was like more education. So I think finding the domain that you like, finding a cool project online and trying to replicate it. Google Colab is a great resource. If, setting up a Jupyter notebook is really hard, but also Kaggle has notebooks too. I think if you just look at other people's projects and then try to make your own project, and then like there's a really great community in women in data science and a lot of other really great data communities. So also like putting it out there and asking for input from others too is a really great way. But yeah, I think anything is coming here is starting, like, and I think just figuring out what makes you like it is, and continuing to do more of that is the best part. Also Python. I think Python has been a big reason why I was able to learn. I think it was really intuitive and helpful.
I'm seeing Helen said she's doing a PhD in, is that XAI, Helen? Let me see. That's impressive. And then I'm seeing Liana. What's the X stand for, Helen? And I'm seeing, who else did I go past the other, right, Lena, sorry. I'm taking a linear algebra course for machine learning. Do you have any suggestions in terms of brushing up on math skills to better understand the data?
I
Explain.
can maybe answer that. I think with like math is a really broad term. I think understanding the type of math you'll need, linear algebra is one of them, because linear algebra deals with a lot of like matrices, right? Which are essentially tables. So you're looking at table behavior and understanding like how different, how there's like linear dependencies. So like how different columns affect one another, which is like a great thing to know. There's also something called principal component analysis in linear algebra. And that's something that's really important to know. I mean, not like for beginners, but like down the road, I think it's something that I have come back to. And principal component analysis is essentially like linear algebra way of understanding which columns are important. And just that's a broad way to describe it. As far as math, I think statistics itself helps a lot. So different, you can start with linear regression, looking up the math behind linear regression. Like that is what will directly relate into how you can kind of decide what's the difference between linear regression and logistic regression. That's a statistical concept, but it's what you use when you decide which model to use when you come in with programming. So I would recommend looking up topics like that, and then just kind of making a list of different topics that apply to data and researching them. You wouldn't necessarily need a really deep understanding of any topic unless your goal is to really research the methods. A lot of times having an overview of a lot is a great way to start.
Hi, could I ask Helen a question, please?
Yes, Helen, Mindy has a question for you.
When you say explainable AI, do you mean like with CNNs and being able to sort of map exactly what it is influencing a really good accuracy in a neural net or a GANs or stuff like that? Is that what that PhD is in? I recently did research on that. That's so cool.
Making black boxes transparent. Very nice.
Yeah.
I'm really happy all these different fields that you all are involved in. I actually will just also follow up on what Alleanna said in terms of the question with the math and those types of things. Resource-wise, statistics, yes, having an understanding of the actual models. As she said, you don't have to have you don't have to be a full statistician to understand like the mechanisms of how the models work, but it's really good to have an understanding of the basic ideas in terms of the foundations, because I think when you come to like some of the techniques that they show you all with regression and all these things, to be able to kind of understand the output and what that means in terms of the insights of what the model is doing and how the model works, depending on the types of variables, you'd really need to have that background. I could suggest for those of you who probably are more beginner kind of in the field somewhat and kind of want to extend, if you want to get more insight into probably like the statistical and mathematical aspects, there is a text called it's a statistical learning or statistical learning by Robert Tibshirani, and I'll Google the full name for you all. It's a very popular text. They use it in a lot of the courses. There was an edX course that both Robert Tibshirani and his colleague actually ran, I believe at Stanford or Harvard. I have to remember which university. And that textbook, yes, as Gayatri said, Stanford has really amazing courses. Yes, they do. They really, really do. And that's why I'm really happy that we are really part of that resource, the resource and repository of the WiDS Global, which really originated at Stanford. So we have a lot of the speakers who originated from Stanford University as well, in terms of the global speakers on the pages, on the YouTube pages, where they speak about their backgrounds and where they came from university-wise. But in terms of the textbook that I was mentioning, I'm Googling it now for you all. I think it's Intro to Statistical Learning. And for those of you who want to look into it, there was an edX course on it. I don't know if it's still being run, but you all could also check that out as well. And I will drop it in the chat for you all. So that would really give you a lot of context. Yes, it's Intro to Statistical Learning, and I believe it's Trevor Hasty and Robert Tibshirani. I hope I'm pronouncing his name correctly. Also Elements of Statistical Learning, and they have a PDF of it online, freely available. So I'm actually going to just put it on statlearning.com. So because statistics is my first love, I'm very happy to speak about this part of it, where I'll kind of push you all into that direction of understanding the models from the basic sense of how these models work. So I hope that helps you. I think it was Dina, in terms of following up from what Alleanna said, in terms of the linear algebra and other math type skills. You all could check that out. And anybody else has any questions or comments for us? No problem, Lena. In the meantime, Rihanna will drop a feedback form in the chat while you all are thinking about your last question. So I'll give you all a few minutes just to think about any more questions you want to ask. Ariel is saying statistics is her love as well. Yeah, she did MSc in developmental. Happy to hear that, Ariel. Yes. So, I mean, I'm glad that we all have all these different expertise here. It's really great to have everybody integrated like that. In the meantime, there's the workshop feedback form. So I'm going to just give any last words from anybody? Would Alleanna and Mindy like to give any last words moving on based on the competition or beyond for our audience today?
For the new people, I would say I don't feel like I've been doing this for very long, and I have learned a lot. Once you're willing to learn, it happens really quickly where you reach this point of knowing a lot. It have a lot of resources out there. You just had to be patient and, you know, just keep doing it.
And Alleanna, anything from you?
Sorry, I think I cut out a little bit. Am I sharing advice?
Yes, sharing
Okay.
advice and any more words for them as they move forward, either in the competition or otherwise.
Okay. Yeah, I think just something that I've been thinking about a lot lately is working together with other people with different backgrounds. I think we can even see it and utilizing the community. So I think we can even see in this one call, people are looking at so many different things and learning about so many different things, and really just being able to utilize the communities that we have helps make it feel a lot less scary to try something new. So I would definitely, that's a big part of why I stayed in the field. And so I would encourage anyone to do that as well.
Excellent. Well, thank you so much to our two speakers, Alleanna and Mindy. We really had an enjoyable session, and I'm glad so many of you were able to share some of your experiences. It's really great to have you all on board. Just to remind you that next week we will have our session, which really follows up from what we did today in terms of kind of understanding now in the model training aspect, where do we go from here? So you can feel free to go on our website and find the registration link for the next session. And we really look forward to hearing from you. If you have any questions, if you'd like to reach out to us, just let us know. And I also want to give my last advice. I know sometimes, even for persons who are actually very seasoned in the field, I could speak for myself saying some parts of this can sometimes be intimidating, sometimes feel challenging. You may find yourself working on the cleaning of the data or analyzing the data sometimes for a while, looking at different aspects, and don't ever feel like that is something wrong. I always tell people, make friends with your mistakes and your challenges, and that is actually where you learn a lot. For those of you who are not into the Python aspect of things, just know that on Google Colab and also on, I know on Kaggle for sure, you can switch to R if you are using R. I know some of you use MATLAB a lot as well. You can use MATLAB as well for some of these routines. And there are other automated ML tools available online that you can also, you know, bring into play, if not in a competition, even in your own fields that you can use as supporting tools. So I would like to just thank all of you for attending today. We really appreciated having you in as part of our session. And we hope that you enjoy the rest of your day, night, evening, wherever you are, and look forward to you joining our next session. So thank you to all.
Thank you for having